For centuries, the promise of a machine that runs forever without fuel has captivated inventors. It represents the ultimate dream of free energy, a mechanical system that simply refuses to halt. This obsession dates back to the Middle Ages. Islamic scholars and European engineers relentlessly sketched mechanical loopholes, filling volumes with schematic drawings like these. The prevailing logic relied on overbalanced wheels. By arranging rolling balls and weighted levers, the shifting mass would perpetually pull the wheel downward, forcing infinite, continuous rotation. Those historical drawings might look antiquated, but modern variations of these exact same concepts still relentlessly clog up patent office queues today. The divide here is absolute. Inventors treat perpetual motion as a complex engineering puzzle that just needs the perfect arrangement of parts. Physics treats it as a strict impossibility. When these devices inevitably fail, it is not due to clumsy design or unexpected friction. They fail because their operation requires the outright violation of the foundational axioms of reality. To rigorously evaluate these claims, physics groups all perpetual motion schemes into 3 distinct classes: the first, second, and third kinds. These categories are not based on the gears, magnets, or materials used. They're defined entirely by which specific natural law the machine is attempting to break. The ultimate judge of these systems is the first law of thermodynamics. Its foundational equation dictates the absolute limit of energy transfer. The total change in a closed system's internal energy must exactly equal the net heat supplied minus the work performed. Nature operates a strict, non-negotiable accounting system. Every energy state transformation must perfectly balance out to zero. Perpetual motion of the first kind describes any device claiming to produce a net positive power yield out of a totally closed system. Whether the intended output is mechanical work, electricity, or heat, the machine is attempting to conjure that energy entirely out of nothing. This animated chart maps the energy ledger for a hypothetical closed-loop mechanical generator operating in a continuous cycle. Over a complete loop, the first law constraint kicks in. The total change in internal energy must be exactly zero. Because internal energy change is zero, the consequence is unavoidable. Total work output cannot exceed net heat input. A machine of the first kind demands work output is greater than heat input, even while heat remains at absolute zero. You cannot generate a positive quantity out of absolute zero. Energy can neither be created nor destroyed. Any system designed to output continuous work without a corresponding operational drop in another energetic field breaks this universal equilibrium, making it totally invalid. Perpetual motion of the second kind approaches the problem differently. These machines do not try to create energy, they claim to recycle it perfectly. The specific goal here is to spontaneously convert thermal energy directly into mechanical work with absolute 100% efficiency. While this technically obeys the conservation of energy, it relies on an impossible expectation. It assumes heat extracted from a single thermal reservoir will completely shift into structured work without any heat flowing to a cooler sink. The physicists who formalized the exact boundaries of thermodynamics explicitly refuted this impossibility. The Kelvin-Planck refinement dictates it is impossible to construct a cyclic device that only extracts heat from a single reservoir to perform work. This animated diagram maps the physical barrier to perfect efficiency, the inequality of entropy. Organized directional kinetic energy flows smoothly, but mechanical transformations require interaction. Atomic collisions and friction inevitably degrade this energy into chaotic vibrations, observed as waste heat. This establishes a harsh operational reality. Because of this degradation, the thermodynamic efficiency of any macro-scale mechanical loop is strictly less than 100%. Every physical interaction incurs an irreversible entropy tax. Therefore, any isolated system inevitably depletes its available work capacity, eventually grinding to a complete halt. Perpetual motion of the third kind involves devices claiming to maintain continuous motion indefinitely by totally eliminating macrostructural dissipation, like friction, air resistance, and impedance. Today, inventors often use this category to mask their machines behind complex contemporary technologies, specifically permanent neodymium magnets. The visual appeal is undeniably strong. Complex magnetic arrangements are frequently presented as magical sources of infinite rotary motion. This simulation dismantles the illusion by mapping a static magnetic field, defined as a conservative field. The energetic exchange is strictly balanced. The work required to push an element into a repelling field precisely equals the kinetic energy released when pushed out. Because those values perfectly mirror one another, the net work delivered by a conservative field over a complete geometric loop is exactly zero. Magnets act strictly as structural springs, not energy sources. They can store and release energy, but they cannot generate continuous external power. The final modern loophole attempts to extract macroscopic work from microscopic quantum states, pointing to electrons orbiting atomic nuclei or persistent currents in superconductors. There is a partial truth here. Subatomic particles can indeed occupy ground state energy configurations without any radiant dissipation. But that state of perfect, frictionless motion only exists because those particles perform absolutely zero external macroscopic work. Attempting to link a macroscopic drive system to these delicate microscopic states to draw mechanical energy is a violent disruption. This forced environmental interaction instantly breaks quantum coherence. It introduces macroscale friction and resistance, triggering the generation of entropy. The moment you attempt to harvest mechanical work from a perfectly persistent quantum state, you destroy that state. The entire system is then forced to demand input energy just to continue operating. Real engineering exists far from these hypothetical impossibilities. Functioning systems operate with heavy copper piping and pressure gauges, dealing with actual energy transfer. Perpetual motion fails because it demands universal laws temporarily stop operating. The iron cylinders here prove the inescapable presence of friction. The rules are non-negotiable. Energy must always be precisely accounted for, and the operational tax of entropy must always be paid. The pursuit of free energy was historically beneficial, however. The obsessive failures of early inventors forced physics to rigorously formulate the laws of thermodynamics in the first place. But today it remains a solved dead end. True modern innovation does not try to cheat physics. It focuses on maximizing energy conservation, minimizing mechanical friction, and refining high-efficiency generation systems, doing the hard work of building within the universe's absolute constraints.